1 9/10 seconds.
Measurements everywhere. Measurements of every sort. Measurements being made all the time. But what is measurement? It is a way of telling how big. A way of telling how heavy. A way of telling how hot or cold. A way of telling how far. And a way of telling how much. Measurement is describing things in many, many special ways. But how does measurement describe something? Measurement describes by comparison. The length of one thing, this piece of wood, for instance, is compared to the length of something else, a yardstick. We can also compare the length of a piece of wood to the length of 3 of something else, in this case, 3 one-foot rulers. And what are you doing when you measure how tall you are? You are comparing your height to standard markings in feet and inches on a piece of wood or on a cloth tape. Today, we have measuring tools of many kinds. But long, long ago, there were no measuring tools for man to use. Without measuring tools, how could man describe the size of things? How could he tell others about what he had seen? He would have to compare it to something that was familiar to everyone. It was as long as my arm, he could say. The bear was as tall as I am. When man needed to talk about things, he compared them to the handiest thing he could find, his body. Man used his feet, his arms, and his hands in many different ways. The only trouble was that everyone was a different size. Even when man began to use rods and sticks for measuring, he still had problems. The rods all had to be the same length. So man had to agree upon a standard. No matter how or where they are made, all measuring tools must give exactly the same standard measurement, as they do today. The official weights and measures of the United States are kept by the National Bureau of Standards at our nation's capital. Master copies of the official weights and measures are used in checking all measuring tools made in the United States. But why is this standardization so important? In making a cake, for example, the recipe calls for standard amounts. Not just any cup, but a standard cup. Not just any teaspoon, but a standard teaspoon. For the recipe is a description of how to make a cake. A description using exact measurements to give exact results. The architect's plan is also a description using measurement. A description giving the exact measurements of every part of the building. And with a thorough knowledge of measurement, the engineer turns the paper plans into cement and steel. The engineer can do this because all the measurement descriptions and all the measurement tools are standard. Standard measurement is a basic tool of modern science. One of the most important things in science is careful observation, careful watching, and careful seeing. And when the scientist describes what he sees, he has to do it exactly. He must use measurement. Here, the scientist is finding how hot a chemical must be to melt. He is watching the red compound to tell exactly when it melts. Now, exactly 169.5 degrees. And when a scientist explains something to other scientists, he must use the language of measurement to describe exactly what is happening. The scientist can use measurement to describe what is happening now. And the scientist can use measurement to remember what has happened. The measurements are the scientist's record of an observation or experiment. So the scientist can study the experiment again and again by examining the recorded measurements, or as they are usually called, the data. Most scientific data today are gathered automatically. The scientist may not actually watch the experiment, but he will study the recorded data most carefully. And of course, all measurement involves the use of mathematics. For numbers and numerals are always part of exact description, which is measurement. How does the scientist know which kind of measuring tool to choose? First, he must know what he needs to describe. Does he need to tell how much time an experiment takes? Or does he need to know the exact amount of chemical that is needed? When the solution becomes colorless, the chemist knows that the correct amount of chemical has been used. It might be important to know how much something weighs. Now here, the scientist decided he did not need to be very accurate. That is, he did not need to be exact. The approximate weight of the chemical was good enough. But often, the scientist needs to describe weight very accurately. And if necessary, he can weigh things lighter than a single hair. So the scientist not only chooses what kind of measurement to make, but also how accurate he needs to be. For example, when the anthropologist wants to compare the shape of two skulls, he usually doesn't need to measure any more accurately than to 1 millimeter, which is about a 1/16 of an inch. In fact, the markings on his calipers are just 1 millimeter apart. And for his purposes, that's close enough. Now, the biologist may need to make a finer measurement. Here, he is interested in recording the size of starfish eggs. This one is 70 microns wide. The biologist is measuring to an accuracy of 1/1000th of a millimeter. But we have ways to measure with still greater accuracy. Here, a a specimen of basiluminite is being prepared for the electron microscope. The specimen has been sprayed with some very fine particles which will be used for measurement. The scientist is going to measure by comparing the size of the fine particles to the specimen. Here, the specimen is being magnified 3,000 times larger than it really is. And as the scientist magnifies the specimen so that it looks larger and larger, he measures by comparison, using the little round particles sprayed onto the specimen. They are 1/10 of a micron across, or 1,000 times smaller than the point of a pin. The scientist knows that he can measure any part of his specimen by comparing it to the round balls, even here, magnified more than 100,000 times. The scientist must be sure that his measurements are accurate. In order to be sure that his mistake or error is small, the scientist may repeat his measurement. He may measure the same thing many times. Often each measurement is a little bit different. But by using mathematics to compare all these measurements, he can come up with a very accurate measurement. More accurate than any single measurement could be. Accurate measurement is a vital part of our scientific and industrial progress. Measurement gives the scientist an accurate description of an event such as the test of a turboprop engine. Measurements of all kinds are taken from connections to every part of the running engine. These measurements are carefully written down and describe just how this particular engine ran. But what of the thousands of measurements that were used in making this engine? Many questions had to be asked. How does the metal react to extreme temperatures? Temperatures of almost 3,000 degrees Fahrenheit. And other questions had to be asked, such as, how hard is the metal? And how much stress will it take to break the metal? So there are many kinds of measurement and many ways to measure. But they all have one thing in common. Every measurement is a comparison of some kind. A comparison to a standard. The heaviness of something is a comparison to a certain number of standard weights. Temperature is a comparison to the boiling and freezing points of water. The amount of liquid is a comparison to that held by standard containers. And the amount of time is a comparison to the rotation of the Earth on its axis. Time, to the astronomer, is the most important of all units of measurement. And it is the astronomer that checks the time by which we set our clocks. In astronomy, even distance is measured by time. The distance to the stars must be measured in light years. The distance light travels in 1 year of time. Measurement, the language of accurate description, not only helps us tell about things on Earth, but also helps us describe the endless reaches of space. And as man travels away from his planet, he will still need to tell others about what he sees. New measurement tools may be developed. New standards may be needed, but one thing is certain. Wherever man is, there will be measurement.